Section 4.6 is talking about linear relations. So a linear equation is an equation whose graph is a straight line. Pretty simple to remember. Straight line is a linear equation. Okay, so in order for an equation to be linear, it has to meet 4 different conditions. Our first condition is that it must be able to be written in standard form. And we'll talk about what that is in a few minutes, but it has to be able to be written in that form. Our second one is that there is no exponents. For a variable that is greater than 1. And then our variable in the denominator of any fraction so there can't be an x in our denominator, and then no variables are multiplied together. So these are our 4 conditions for our linear equations. So if we look at these examples here, you can see that number 1, we have no exponents, no x's or y's in our denominator, no variables multiplied together. So this is our linear equation. And standard form, I'm just going to review what that is right here. So standard form of an equation is we have some constant, a, times our variable x, plus another constant, b, times our variable y, equals some other number, or constant, c. So a, b, and c are constants. So those are going to be numbers like 3, 5, -7, 1/2. All those are examples of constants. 0.3. Those could be a, b, or c. Any number like that could be a, b, or c. Our x and y are our variables. So that is what is meant by standard form. If we look at number 1, number 1 is written in that standard form. It's got a constant 3 times x, a constant 2 times y, and then equals some constant. So that is in linear form. Number 2, we have an exponent, so right away we can say not linear. Number 3, we have no exponents, no variables in our denominator, no variables being multiplied together, and this one is tricky to see, but it actually is in standard form, because if we had if b equals 0, then we would get an a equals 1, we would get x plus 0, well, there should be an equal sign right here, equals c, which is x equals some number, c. That's what we have right here, x equals -4, our c is -4. So that is in our standard form, so that is linear. Number 4. Now, if the standard form is confusing you, then really all you need to look at are these 3 conditions, 2, 3, and 4, to help you figure out if these are linear or nonlinear. And if they meet those, they usually can be written in standard form. So if we look at number 4 here, there's no exponents, no variables in our denominator, and no variables are being multiplied together. So this one we can say is linear. Number 5, we've got x times y right here. That is violating our rule number 4. Our variables are being multiplied, so this is not linear. And then number 6, our variables are in a denominator. So again, violating rule number 3, not linear. Okay, so our next part says to graph a linear equation on a coordinate plane, we need to do the following 6 steps here. First one, make a table with 4 columns. If we look at our example down here, number 7, it already has our table for us. Number 2, choose a reasonable domain of 3 values. So if we were to pick a domain for x, it is much easier to use whole numbers. So I'm going to just pick -1, 0, and 1. Those 3 numbers are easy for us to deal with. You could pick any 3 numbers for our domain here, but I'm just going to choose those 3. Then we're going to substitute the domain into the equation to find the range. So if we plug in these numbers, we have a -1, -2, 0, -2, and 1, -2. -1 minus 2 is -3. 0 minus 2 is -2, and 1 minus 2 is -1. So our points here are -1, -3, 0, -2, and 1, -1. So we did step number 4. We wrote the domain and range as an ordered pair. And our next step, number 5, is to graph. So if I have -1, -3, 0, -2, and 1, -1. Graph my points, and then finally draw a line through the 3 ordered pairs and place arrows on either side. So this is how I am able to graph my linear equation on my coordinate plane. So we've got 4 more examples of how to graph these equations. I'm going to do the next one with you, and then you're going to try a few on your own. So we have our equation, y equals -3x. So I'm going to pick my 3 points. Again, I'm going to stick with -1, 0, 1, just because I know they'll be right in the middle of my graph, and they're easy numbers to work with. But remember, you can pick any 3 reasonable numbers. Then I'm going to plug them in. -3 times -1, -3 times 0, and -3 times 1. -3 times -1 is 3. 3 times 0 is 0. -3 times 1 is -3. So then I can write my points together. I've got -1, 3, 0, 0, and 1, -3. My next step is to graph. So I go -1, 3, 0, 0, and 1, -3. And then once everything is graphed, I'm able to connect my 3 points with a nice straight line. Okay, so I'm actually going to do the next one with you too, and then you're going to try number 11. So number 9 and 10 are a little different because they only have one variable. In number 9, it says graph y equals -1. When we graph y equals -1, if we look at this -1 point here, y equals -1, that means that no matter where we are, our y is always going to equal -1. So we can choose our numbers here like we did before, but there is no x to plug in, so our domain is always going to be our range, our y is always going to be -1. No matter what our domain is, our range is always -1. So we have our points -1, -1, 0, -1, and 1, -1. So I've graphed those points. I have -1, -1, 0, -1, and 1, -1. And when I connect those points together, it is just a straight line at my point -1. So if we look at number 10, it's going to be very similar, except in this case, my x equals 4. So if my x equals 4, that means my range here is always going to equal 4. It can't equal anything else. So when I try to find my range here, there is nothing I can plug in for y. So no matter what points I have, over here for y, no matter what points I have, my x is always going to equal 1. It's the opposite of what we did in number 9, because this is telling me my x always equals 4. So no matter where my y is, my x is always going to equal 4. So I can graph my points here. I have 1, 2, 3, 4, 1, and -1, and 0. When I graph those points, I get a straight line up and down at x equals 4. Okay, so we have one more here. When we look at this one, this is what we were doing earlier, like in number 8. So I'm going to pick my points. I have -1, 0, 1. When I plug those in, 2 times -1 plus 1, 2 times 0 plus 1, and 2 times 1 plus 1, I get -1, 1, and 3. So my final points, I have -1, -1, 0, 1, 1, 3. Can graph those over here. Go left, -1, down 1, 0, 1, and 1, 1, 2, 3. Those are my 3 points here. And this is my graph for number 11. This is my graph of y equals 2x plus 1.